Let us look at facility location planning using the center of gravity method. The Mumbai Baking Company currently has 4 retail locations within the metropolitan area of a major city. Currently, each retail outlet makes all of its own breads and pastries from scratch. In order to reduce costs and ensure consistency of the firm's products across all locations, the management has decided to build a central commissary where the products will be prepared and subsequently distributed to the 4 retail stores. The question now is where to locate the commissary. So of course the criteria to choose the location of the commissary would be at a place where the total cost of transportation to all these 4 store locations is minimized. Now we have been given the X and Y coordinates of each of these 4 store locations, and we have also been given the quantity of product being sold at each of these stores. So now we have to find out where does it make sense to locate this commissary. So let us first understand what is meant by the center of gravity method. The center of gravity method is a quantitative technique that can be used to determine the optimal location of a facility based upon minimizing the transportation costs between where the goods are produced and where they are sold or redistributed. So the first step in the center of gravity method is to locate each of the existing retail operations on an X and Y coordinate grid map. And this grid map will help us in establishing the relative distances between these locations. So step 1 is to locate each of the existing facilities on an X and Y coordinate grid map. And step number 2 is to find out the X and Y coordinates of the new plant by taking the weighted average of the X and Y coordinates of all the existing facilities. So step number 2 is find out the X and Y coordinates of the new plant by taking the weighted average of the X and Y coordinates of all the existing facilities. So now let's look at the formula for finding the X and Y coordinates of this new plant or new location. So XO is the X coordinate of the new location which we are trying to find, is equal to the sum of the multiplication of xi and li divided by the sum of li, and the y-axis is y is equal to sum of the multiplication of the y coordinates and li divided by the sum of li. Now here x0 and y0 are the coordinates of the new facility. Xi and yi are the coordinates of the existing facilities, and Li is the load to be transported between the existing facilities and the new plant. Load to be transported between the existing facilities and the new facility. So let us look at this further by means of solving this given example. So here we have completed step number 1, which is to locate each of the existing facilities on the x and y coordinate grid map. So this is the x-axis, this is the y-axis. Basically this exercise is being done to find out the x and y coordinates of the existing locations. Now let's move to step number 2. This step is to find out the weighted average of the x and y coordinates of the existing facilities. Now the formula is x0 is equal to the sum of the multiplication of the x coordinates of the existing facilities and the load being transported between the existing facility and the new facility divided by the sum of all the load which is being transported. So let's find this out. So let's say first we consider I as A. So the x coordinate for A is 125 multiplied by the load being transported between A and the new plant or the new facility, which is 1250, plus next is B, so 250 multiplied by 3000, plus C 450 multiplied by 2750, plus 200 multiplied by 1500, and this whole divided by the sum of all the loads, which is 1250 plus 3000 plus 2750 plus 1500, and this is equal to, so let me pull my calculator here. So 125 multiplied by 1250 plus 250 multiplied by 3000 plus 450 multiplied by 2750 plus 200 multiplied by 1500. So this is 244 3750 divided by 1250 plus 3000 plus 2750 plus 1500, 8500. So 2443750 divided by 8500, and this is equal to 287.5. 287.5. This is the x coordinate of the new facility. Now let's move to find out the y coordinate. So y coordinate again will be the same, sum of yi multiplied by li divided by the sum of li. So this is equal to, for a, the y coordinate is 100, so 100 multiplied by the load being transported between the facility A and the new facility, plus for B 75, so 75 multiplied by the load, which is 3000, plus for C 300 multiplied by the load, which is 2750, plus for D 350 multiplied by the load, which is 1500, and this whole divided by the load, which is 1250 plus 3000 plus 2750 plus 1500. So let me again pull my calculator. So 100 multiplied by 1250 plus 75 multiplied by 3000 plus 300 multiplied by 2750 plus 350 multiplied by 1500. So the numerator is 1700000 divided by the denominator, and denominator we had found out earlier, which is 8500. So this is equal to, so divided by 8500, 200. So the y coordinate of the new facility is 200. So let us locate this new coordinates or the new facility on this grid map. So 287.5, which is the x coordinate, will be somewhere here, and the y coordinate, which is 200, will be somewhere here. So this will be somewhere around here. This is the new facility with coordinates 287.5 and 200.